secant inverse of x square plus 1 by x square minus 1. We have to find out derivative of this particular thing with respect to x. Okay, take it as y. Then in this particular function, to find its derivative, I am assuming x is equal to tan theta. So if I assume x is equal to tan theta, y can be written as secant inverse of tan square theta plus 1 by tan square theta minus 1. So we have tan square theta plus 1. 1 plus tan square theta is equal to secant square theta. So secant square theta by tan square theta minus 1. We can't write it like any other form. So I write it as tan square theta minus 1. Now still, see, these are all things we are doing to convert this particular thing in terms of secant theta, because we can write secant inverse of secant theta as theta. So I am checking for that ways. So I got till here and I am not able to express this one in terms of secant theta. So still I have to do simplification. So what simplification I can do? So I just write this everything in terms of sine and cos. So if I write secant square theta in terms of cos, I get 1 by cos square theta whole divided by tan square theta minus 1. So you see, tan square theta can be written as sin square theta minus sin square theta by cos square theta minus 1. So if I take LCM, I get cos square theta. So numerator sin square theta minus cos square theta. So what I can write is tan square theta minus 1 sin square theta minus cos square theta by cos square theta. Now cos square theta and cos square theta get cancelled. So we have cos square theta minus sin square theta as cos 2 theta, and here I have sin square theta minus cos square theta. Then it can be written as minus cos 2 theta. So I replace it, then I get secant inverse of 1 by minus cos 2 theta. This can be written as secant inverse of, I write here, secant inverse of minus secant 2 theta. Secant inverse of minus secant theta. So we have secant inverse of minus x. Secant inverse of minus x as pi minus theta. Nothing but we can write it as pi minus 2 theta. What we can write? Pi minus 2 theta. So substitute here. So I get pi minus 2 tan inverse of x. Now I want to find dy by dx. So derivative with respect to x. I have a pi, which is a constant. I get 0 minus 2 as it is, 2 into d by dx of tan inverse x, which is nothing but 1 by 1 plus x. So what is my final answer? Minus 2 by 1 plus x square. Next question. First, the rest of the questions they have given the hints, follow the hints and solve the problems. So we go to 17th one. 17th first, cos inverse of 17th first, cos inverse of sin x plus cos x by root 2. Sin x plus cos x by root 2. Consider the entire thing as y. So I took it as y. Next, see, I have here cos inverse. I should be able to express this entire thing in terms of cos. So just recall trigonometry, that while finding range and domain, what procedure we opted, the same thing I am going to opt here. So I get this one as y is equal to cos inverse of 1 by root 2 into sin x plus 1 by root 2 into cos x. So 1 by root 2 can be written as sin pi by 4. 1 by root 2 can be written as cos pi by 4. So I replacing that y is equal to cos inverse of here sin pi by 4. Why I am not writing this 1 by root 2 as cos pi by 4? I want here cos inverse of cos. Cos inverse of cos. So cos a plus b or cos a minus b. If you go to cos a plus b or cos a minus b, we get cos a cos b minus sin a sin b. If you go to cos a minus b, cos a cos b plus sin a sin b. Right? I want to express, that's why in that form. Right? Sin pi by 4 into sin x plus cos pi by 4 into cos x. Cos a cos b plus sin a sin b, which can be written as cos of a minus b. So I am writing it as y is equal to cos inverse of cos a is pi by 4. So pi by 4 minus b is x. So cos inverse of cos, we get cos inverse of cos theta is theta. So y we get as pi by 4 minus x. So if I do derivative with respect to x, dy by dx is equal to pi by 4 is a constant 0 minus x derivative is 1. So my answer is minus 1. We move to the next question. Cos inverse of cos inverse of 3x plus 4 root 1 minus x square by 5. 1 minus x square by 5. So again we just consider this one as y. Now I have to convert the entire thing in terms of cos. So to convert that, I have here x, here 1 minus x square. So in this particular case, what we can do? We can substitute x as cos theta or sin theta. So I want to prefer this one x as cos theta. Reason, if I put here cos theta, I can express this one in terms of cos, then I can go for cos formula. So I want to apply in that way. That's what I am using x as cos theta. If x is cos theta, what about theta? Theta is equal to cos inverse of x. So now y is equal to cos inverse of 3 by 5 into cos x, cos theta plus 4 by 5 of root of 1 minus cos square theta sin square theta. So you see here in inverse functions, what we have to consider? So where the 2 exists. See 1 minus cos square theta, I kept here cos square theta, what we get? Sin square theta. So we get the region in between minus pi by 2 and pi by 2. In between minus pi by 2 and pi by 2, cos is always positive, right? That's why I take only positive here, which is nothing but sin theta. Now I have to express this one in the form of cos a plus b or cos a minus b. For that, what I am taking 3 by 5, I substitute as r cos alpha. 4 by 5, I substitute as r sin alpha. 3 by 5 as r cos alpha, 4 by 5 as r sin alpha. Then what is the value of r? So r is equal to, so r how we get? Squaring and adding. So r square into cos square alpha plus sin square alpha is equal to 3 by 5 whole square, 9 by 25 plus 4 by 5 whole square, 16 by 25. So 9 plus 16, 25, 25 by 25, 1. So r square into 1 is equal to 1. R is equal to modulus of 1, but here we have to consider r as always positive. So we get r is equal to plus 1. Now replace this, y is equal to cos inverse of r cos alpha. R value already I got, which is nothing but 1. So 1 into cos alpha. So cos alpha cos theta plus 4 by 5. 4 by 5, which can be written as r sin alpha. So r value 1. Sin alpha and sin theta. Now y is equal to y is equal to cos inverse of. So what we are getting? Cos A cos B plus sin A sin B. Cos A minus B. So what we get? Alpha minus theta. What we get? Alpha minus theta. What is the alpha cos of cos inverse of cos alpha minus theta? Now y is equal to alpha minus theta. Theta is given as cos inverse x. That implies y is equal to alpha minus theta. Substitute cos inverse of x. Now dy by dx is equal to, alpha is a constant, we get 0, minus cos inverse x, derivative of cos inverse x with respect to x is minus 1 by root of 1 minus x square. Minus into minus plus. Therefore dy by dx is equal to 1 by root of 1 minus x square. We shall move to the next problem, which is sin inverse of question number 18. First, sin inverse of 6x minus 4 into 1 minus 4x square under root by 5. Find the derivative. Yeah, previously we have done two problems. We can do this one also in the same way. Just I will give the hint. You have to complete this problem. See, I have here 1 minus 4x square. If I have 1 minus x square, directly I can substitute in place of x some cos theta or sin theta. But I have here 1 minus 4x square. So 4x square can be written as 2x whole square. So in this case, what we have to do? Substitute. Put 2x is equal to, I have here sin, I want to write in terms of sines, right? 2x is equal to sin theta. 2x is equal to sin theta. Then x is equal to sin inverse of, theta is equal to sin inverse of, sin inverse of 2x. Take the problem and solve. Next, we go to the second one. Tan inverse of x power 1 by 3 plus a power 1 by 3 by 1 minus x power 1 by 3 into a power 1 by 3, which is equal to, take it as y. I want to find its differentiation. By seeing this problem, we can understand clearly it's in the form a plus b by 1 minus ab. Nothing but tan a plus tan b. Why I am taking in terms of tan? Outside I have tan inverse. So if I consider this particular part as tan a plus tan b by 1 minus tan a tan b. Tan a plus tan a plus tan b by 1 minus tan a tan b, which will be equal to tan of a plus b. Right? So I can use that. Let tan a is equal to x power 1 by 3. Tan b is equal to a power 1 by 3. So according to this, what we get, a is equal to tan inverse of x power 1 by 3. B is equal to tan inverse of a power 1 by 3. In this particular case, we should remember that a is a constant. A is constant, right? Now y is modified as tan inverse of tan a plus tan b by 1 minus tan a tan b. Now tan a plus tan b by 1 minus tan a tan b can be rewritten as tan of a plus b, tan inverse of tan of a plus b. Now tan inverse of tan theta is theta, nothing but tan inverse of tan x is x. So we get y is equal to a plus b. I substitute a and b values. A is equal to tan inverse of x power 1 by 3. B is equal to tan inverse of a power 1 by 3. Take derivative, dy by dx is equal to tan inverse of x, derivative of tan inverse of x 1 by 1 plus x square. So in place of x we have x power 1 by 3. So definitely we have to do its derivative again. So derivative of x power 1 by 3, 1 by 3 into x power 1 by 3 minus 1, n into x power n minus 1 plus, it's a constant, so tan inverse of constant is also equal to a constant, so we get derivative as 0. Now dy by dx is equal to 1 by 3 into x power 1 by 3 minus 1, so 1 by 3 minus 1, which is equal to 1 minus 3 by 3, nothing but minus 2 by 3. If I take it to denominator, I get x power 2 by 3. So we get it as 1 by 3 into x power 2 by 3 of 1 plus x power 1 by 3 whole square. A power m whole power n, a power m into n, we get it as 1 plus x power 2 by 3. So before going to implicit differentiation, we should know two things. What do you mean by implicit function and what do you mean by explicit function? Till now while doing differentiation, whatever the function given, they have given like sine of x square plus 2 or cos inverse of 2x plus 3. So this type of functions they have given, I took this as equal to y or equal to y. So what I mentioned here, so sine of something I consider as a function in terms of x which is defined as y. Nothing but here one variable y is expressed as one more variable x. So we are able to express one variable in terms of other variable. Those type of functions are called explicit functions. So whatever the differentiation till now we did, those are nothing but explicit differentiations. Now we are going to implicit differentiation. Implicit differentiation, first we have to know what is implicit function, like this. So if you have a function like x square plus y square plus xy equal to 0, right? We have an equation. Before saying as a function, let it be an equation. So in this particular equation, I cannot express either y in terms of x or x in terms of y. So I cannot able to express x as a function of y or y as a function of x. So I am failing in that condition, even though the value of these equations, so at particular point of y, if I take the value of y as 1, the value of x changes. Yes or no? If I take value of y as 1, what I get, x square plus 1 plus x equal to 0. From this what you get, x square plus x plus 1 equal to 0. If I substitute the y value as 2, what I get, if I substitute x square plus 4 plus 2x, which is equal to 0. See, the value of x depends on y. In a similar way, if I consider x, the value of y depends on x. The value of y depends on x. Even if you are not able to express this one completely in terms of x, y as y or y in terms of x, we can say those type of functions are implicit functions. Finally, what do you mean by implicit function? One variable cannot be expressed as another variable. Say f of x comma y is an equation. We are not able to express f of x as y, y as a function in terms of x, or f of y as x, f of x as y, or f of y as x, x as a function in terms of y. We are failing in this. Those type of functions differentiation. We are going to see those type of functions differentiation. Now, what we discussed in this particular case, even we are not able to express x in terms of y or y in terms of x, the values of x depends on y or the values of y depends on x. So in that particular case, what we have to do, consider let the function is defined in terms of y. Let x regarding, we can mention it, regarding x is a function. X is a function in y. So if x is a function in y, so in what way I can differentiate the equation? I can differentiate the given equation with respect to y. So I can find here dx by dy. Or if I express, if I feel, let y is a function in terms of x. If y is a function in terms of x, then what we do? We find differentiation of y with respect to x. So here two cases exist, dx by dy or dy by dx. And in a previous cases we have learned always dy by dx into dx by dy is equal to 1. So we see some problems to prove these particular conditions also. So let me discuss few problems to get a better idea. I hope you understand. Let a function given x minus y is equal to, x square plus y square equal to 25. I have x square plus y square equal to 25. X square plus y square equal to 25. Find dy by dx. X square plus y square equal to 25. Find dy by dx. Yeah. To find dy by dx, what we have to consider? The given function is given in terms of x. Let y is a function in terms of x. What we have to consider? That y is a function in terms of x. Y is a function in terms of x. Then we can find out derivative of y with respect to x. So here I have x square plus y square is equal to 25. We cannot say it is implicit function or explicit function. Can we say this one as explicit function? Sir, I can able to express x square as 25 minus y square, and I got x is equal to root of 25 minus y square. See, whenever we get root, what we get? X is equal to plus root of 25 minus y square or minus root of 25 minus y square. I am getting two values for one x. For one x I am getting two values. That's why we are calling this one as implicit function. It is not explicit function. We cannot able to express either x in terms of y or y in terms of x. So we see the differentiation with respect to x. So differentiation of x square with respect to x is nothing but 2x. Differentiation of y square with respect to x, 2 into y, it is not x. That's why we have to do again derivative, which is equal to 0. Now I want dy by dx. So dy by dx is equal to plus 2x, so right side minus 2x. 2y is multiplying, so I take it as division. So 2 gets cancelled. I get minus x by y. Next, one more question. I have x square. Sorry, I take the question. Second, x cube plus x square y. Third, second, x cube plus x square y plus xy square plus y cube plus xy square plus y cube, which is equal to 81. Right. So I want to find differentiation of this with respect to x. They asked us to find dy by dx. They asked dy by dx. So I feel regarding y as a function in terms of x. Y as a function in terms of x. That statement we have to write for all these type of problems. Right. Now I am finding its derivative. X cube derivative with respect to x is nothing but 3x square. Now I have here x square and y. I have to apply UV formula. X square into dy by dx plus y into x square derivative is 2x. I have completed this particular part and to this one again, which is in the form of uv. So I have to apply uv formula. X into y square. I feel it is x square. I get 2y, but it's not x, so I have to do again differentiation dy by dx. dy by dx plus y square into differentiation of x is nothing but 1 plus I have y cube purely in terms of y, so I get 3y square into dy by dx equal to constant, we get 0. Now separate all derivative parts one side and rest of the thing other. So 3x square, y into 2x nothing but 2xy and y square. So I get 3x square plus 2xy plus y square. See, if I take dy by dx common in the other things, dy by dx, what we can expect? dy by dx into, here leftover is x square, here again 2xy and here 3y square, which is equal to 0. Now I want dy by dx. So dy by dx is equal to minus of 3x square plus 2xy plus y square whole divided by, this particular part is multiplying, so divides x square plus 2xy plus 3y square. So this is the differentiation what we got. And the next question, find dy by dx if x square plus y square whole square equal to xy. So it's nothing but similar way you can solve this. The fifth one, first part, x square plus y square whole square is equal to xy. So they asked us to find dy by dx. So what is the first point? Regarding y is expressed in terms of x. Nothing but y is a function defined in x, right? So I have x square plus y square whole square. I just split using the formula a plus b whole square. So I get x square plus, x power 4 plus y square whole square, y power 4 plus 2 x square y square, which is equal to xy. Now I apply dy by dx and we can simplify. So if I apply dy by dx, what I get? 4 x cube plus 4 y cube into dy by dx plus I have here uv form 2 common, which is a constant, 2 into x square into differentiation of y square 2y into dy by dx plus y square into differentiation of x square 2x, which is equal to, I have xy, so again for that also I have to do differentiation uv form x into y derivative dy by dx plus y into x derivative is 1. Separation means all derivatives I sent left side, other things I sent right side. So all derivative I have here 4 y cube into dy by dx plus 2 2s are 4 x square y dy by dx. So if you send to left side, we get minus x into dy by dx. So these all I am transferring to right side. What I get? Minus 4x cube, and here 2 2s are 4 minus 4xy square. So already I have here y, so I take plus y. So take dy by dx common and send the rest of things right side. So I took dy by dx common equal to minus 4x cube minus 4xy square plus y by 4y cube plus 4x square y minus x. This is the answer. Square y plus 4y cube minus x. Right. We move on to the next question, which is given as x cube plus y cube is equal to 3axy. Prove that dy by dx into dx by dy equal to 1. x cube plus y cube is equal to 7. Second one, x cube plus y cube is equal to 3a xy. Now they asked us to prove dy by dx into dx by dy which is equal to 1. So two cases will arrive later. We find out dx by dy and dy by dx. We just do multiplication. Right. So case 1 I am finding dx by dy. So with respect to y I have to mention. So dx with respect to y, derivative of x with respect to y. So we get 3x square. So we are doing with respect to y. So if it is y, no issue. It's not y. So I have to do derivative dx by dy. Now it is y. Previously, once you just go through the previous question, dy by dx. Whenever we get y, we wrote it as dx. Sorry, dy by dx, because we are doing differentiation with respect to x. But here we are doing differentiation with respect to y. So y cube we have 3y square. So dy by dy nothing but 1. So no need to consider that. 3a into u form x into y derivative with respect to y 1 plus y into x derivative with respect to y. Okay, right. Now, so separation, I have 3x square into dx by dy minus 3ay into dx by dy, which is equal to 3ax minus 3y square. You see everything we have a 3, so all the terms contains 3. So we can take 3 common and we can eliminate. So I can eliminate that 3. So if I eliminate all the 3's, just don't cancel like this. Take 3 common and eliminate, and take dx by dy common. I get x square minus ay, which is equal to ax minus y square. So dx by dy is equal to ax minus y square by x square minus ay. So I got this particular thing. So later I do differentiation with respect to x. So I am finding dy by dx. So I am doing with respect to x. So differentiation of x cube, we get 3x square into dx by dx is 1, plus differentiation of y cube, we get 3y square, but we are doing y with respect to x, we get dy by dx, which is equal to 3a constant. Next we have xy, differentiation of y with respect to x, which is nothing but dy by dx, plus y into differentiation of x with respect to x is 1. Now what we get? So again we have here 3, 3 and 3. So we take common and cancel. So we get here y square into dy by dx. So I get 3 already, I did cancellation. So I have to eliminate it. Ax, so minus ax into dy by dx, which is equal to ay minus x square. So take dy by dx common, dy by dx common equal to ay minus x square. I took common, I have a y square minus ax. So that y square minus ax I am transferring to right side. So what we get? Y square minus ax. Now do the product. Dy by dx into dx by dy is equal to ay minus x square by y square minus ax into ax minus y square by x square minus ax. See, I have x square minus a y, this one. I have ay minus x square. So in numerator I can take minus common. I get x square minus ay. In denominator again I take minus common. I get ax minus y square into ax minus y square by x square minus ay. So x square minus ay gets cancelled. Ax minus y square and ax minus y square gets cancelled. Minus by minus plus. So we got answer as 1. Sin x is equal to y into sin x plus a. Prove that dy by dx is equal to sin a by sin square x plus a. Right. So I have to take its derivative. So derivative of sin x with respect to x, cos x. Now we have in the UV form. So y into d by dx of sin x plus a cos x plus a, and it's not x. So if I do derivative of x is 1 and derivative of a is 0 plus sin x plus a into so derivative of y with respect to x is dy by dx. So here the two things what we have to remember. I have a function like x and y. I am differentiating x with respect to x. Then what we get? Dx by dx. Differentiating y with respect to x, then we get dy by dx. So dy by dx only, but dx by dx we get 1. Same, these two are differentiating with respect to y. So we have in denominator y. Then we get dx by dy, and here dy by dy. So in this particular case we get 1. If we have a clarity in this particular thing, we do many problems without any confusion. Okay, let me continue the problem. Right, now I want to find dy by dx. So I take dy by dx as my subject. So before taking this one as a subject, I have to send this one to left side. So I get cos x minus y into cos of x plus a, and this particular thing is multiplying dy by dx. So definitely it will divide this particular thing, which is nothing but sin of x plus a. Now till here it's okay. I compare with the answer. In answer I don't have y, but here I have y. So I have to eliminate this y. For the purpose, what we have to do? We have to substitute y from the given equation. So what is the value of y? Y is equal to sin x by sin x plus a into, as usual, cos x plus a whole divided by sin of x plus a. Now take LCM. So we get sin x plus a into cos x minus, I calculate this one first, cos x plus a into sin x whole divided by the sin x plus a will come to denominator, so into the same thing we get sin square x plus a. Now you see sin x cos y minus cos x sin y, which is nothing but sin of x minus y. So I get sin of x is x plus a, y is x, by sin square x plus a. Minus x plus x gets cancelled. I got sin a by sin square x plus a. By seeing the first one, sorry, this problem got over. Come to the problem number 1. You have to solve 10th main question number 1. We have denominator something, don't bother about it. Simply in this way you solve, we get the answer. Next, take 11th main, one of the question. Take it first one. Take the first question. Given y is equal to root of x plus root of x plus root of x plus and so on infinity. Prove that 2y minus 1 into dy by dx equal to 1. 2y minus 1 into dy by dx equal to 1. Okay. So I want to prove this for the particular thing. So I consider the given thing y as this all, right? X plus root of x plus root of x plus and so on infinity. So from that infinity, if I subtract 1, is there any change? Infinity minus 1 is nothing but equal to infinity. So that's what I want to do is y is equal to root of, I just use this x as x only, I take this entire part as y. As they have mentioned, y is equal to root over x plus root over x plus root over x plus and so on infinity. So in that all infinities, I just left one x and the rest of the things I have used as y. Now take the squaring on both sides. So we get y square is equal to x plus y. Take differentiation. 2y into dy by dx is equal to x plus dy by dx. Sorry, derivative of x is 1. Now left side this side, we take 2y minus 1 into dy by dx. I took dy by dx common, which is equal to 1. Similarly, they have given in terms of tan and sine. So we shall do the problem which is mentioned in terms of tan. In terms of tan, third, y is equal to tan x plus tan x and so on infinity. We should mention square roots for this all. Right. Prove that 2y minus 1 into dy by dx. 2y minus 1 into dy by dx. What is the derivative of tan x here? Secant square x. Tan x is secant square x. Previous case, we have everything in terms of x. We have everything in terms of x. So what is its derivative? Nothing but 1. So if you have here cos x, what is its derivative? Sin x. If you have cos x, its derivative sin x. If it is given in terms of secant, what do we get? Secant x derivative. What is the secant x derivative? Secant x into tan x. If it is cot x, minus cosecant square x. So what we got here, that reflects there. See, if I take this particular thing as y, now I can write it as y is equal to root over tan x plus entire thing as y, taking squaring on both sides. Y square is equal to tan x plus y. Differentiating with respect to x, we get dy by dx, means 2y into dy by dx, which is equal to differentiation of tan x, secant square x plus dy by dx. Send to left side. So if you transpose to left side, we get minus. So 2y minus 1 into dy by dx, which is equal to secant square x. So left side part is same. We are getting 2y minus 1 into dy by dx. Right side is reflecting derivative of the particular variable. If suppose I have a function like y is equal to root over x square plus 1 into root of plus root of x square plus 1 plus root of and so on, then what we are expecting right side? Nothing but the derivative of 2x x square plus 1, which is nothing but 2x. You try the problem given as y is equal to root of x into x and so on infinity. So I am not using here plus, I am using multiplication. Right? This problem you will work.